Good morning, our students, and welcome to this morning's class. Today, we'll be discussing with you a very important topic in statistics called analysis of variance. Analysis of variance. Analysis of variance. This analysis of variance is written in a short form, ANOVA. Is written in a short form, ANOVA. So anytime you see a term ANOVA, it is referring to analysis of variance. That is what we have to discuss today. And as a way of introduction, there are certain concepts or terms that we ought to look at first before discussing in detail this concept of analysis of variance. Because understanding those terms implies understanding the discussion on ANOVA. And what are these terms? The terms are, we have what we call factor, or we call it independent variable. Independent variable. We equally have what we call treatment. Have what we call treatment. We can equally call it what? Level of a factor. We can equally call it what? A combination of levels of what? Of factor. A combination. Combination of levels of factor. We equally have another concept called experimental unit. Experimental unit. We have experimental unit. There is equally another concept which we call the experimental plot. Experimental plot. Plot. We equally have what we call replication. Call it replication. Replication. And then we equally have what we call randomization. Randomization. So we want to understand these concepts before diving into discussing the analysis of variance ANOVA. What do we mean by a factor or experimental or independent what variable? In the study of analysis of variance ANOVA, a factor means that variable whose effects we want to study in an experiment. That is what we refer to as what? As factor. In this concept, it could be a drug which we want to study its efficacy. And this drug is applied on, say, human beings or animals. Now, this factor applied on human beings or animals have to have effects on them. And we really want to study the effects of these factor on these animals or human beings. So factor could refer to drug applied to animals or human beings. It could refer to manure applied to what? To crops, which of course will have effect to those what? Crops in terms of their growth or in terms of anything. So studying the growth of what? Of crops in that concept implies studying the effect of what? Of this factor. So any variable in experiment or a research in which we are interested in studying its what? Effects is what we refer to as factor, otherwise called independent variable. Do remember that in regression, we define independent variable as that variable that have effects on the dependent what variable, or the variable that the researcher is interested in studying its effects. That's what we refer to as what? As a factor. Then when we come to what? To treatment, effort should be made to distinguish between factor and a treatment. Treatment is a specific quantity or level of a factor that is applied on the experimental unit. I will explain. When we talked about what factor, we talked about a variable whose effect we want to study. And this variable could be drug, for instance. And this drug is taken by either animals or humans now with the intention of curing their sickness. Let's consider, for instance, a drug that is made to cure headache. And of course, you know that there are different kinds of drug that cure headache. Some of which are, we have the Fensic, we have the Panadol, we have the Panadol Extra, and many other drugs that equally cure headache. So in generality, this drug is a factor, okay? But that specific level of the factor, which could be Fensic, which could be Panadol, or which could be Panadol Extra, is what we refer to as what? As a treatment. So it is a specific unit or level or measurement of what? A factor that is applied on experimental units. That's what we refer to as what? As a treatment. That's the reason why here, I call here what? A treatment. I equally can call it what? A level of factor, because in the analysis I've just given, we are looking at what? Drug as what? As a factor. What are the levels of this factor? They are those other kinds of drugs which are taken to arrive at the same result, which is curing the headache. So the levels of this drug in this context are the Fensic, the Panadol, and the Panadol Extra. There are still other kinds of drugs that are targeted of curing of headache. They fall under the levels of of this factor. Now, I can equally call it a combination of levels of of a factor, because we can have more than one factor in an experiment, and then we combine different levels of this factor now, targeted to achieve a coordinated effect on experimental units. And on that note, we can equally call it what? A level of a factor, and equally call it what? A treatment. So if you are taking something like, or even if you talk about fertilizer, and in fertilizer, you are talking about different kinds of fertilizer, the 2010-10, the NPK, 2010-15, and so many other kinds of fertilizer, like the nitrogen fertilizer and the rest of them. So in generality, we are looking at fertilizer as a factor, while we are looking at either nitrogen fertilizer, either phosphorus fertilizer, either 2010-10 fertilizer as the levels of of a fertilizer. So that's what we mean by treatment. Then when we now come to what we call experimental unit. Experimental unit is the item, the object, which it could be animal, which it could be human beings, which could be plants, or anything you can think of, upon which we apply our experimental treatment. Consider, for instance, when I gave illustration of drug and a human being. Human being is an experimental unit, because it is on human being that this treatment or level of factor is applied. So that's what we call experimental unit. When I gave the analysis of a fertilizer and a crops, for instance, let the crop be be maize, to be specific. And then these treatments are applied on on maize. So the maize there becomes the experimental unit, upon which the experimental treatment is what is applied. That's what we mean by experimental units. When we talk about experimental plot, we are talking about the specific point or place on the experimental unit on which the experimental treatment is what is applied. For instance, there are some injections that are given at the buttocks. Some are given as what? At the vein, through the vein in the hand. So in that case now, when it is given in the vein through the hand, we are referring that particular spot on the hand as what we call the experimental what plot. The spot or the particular place on the experimental what unit upon which the experimental treatment is what is applied. That's what we call the experimental what plot. Then when we talk about what replication, we are talking about the application of the same experimental what treatment to the same experimental unit for more than what once. That's what we call replication. Application of the same experimental what treatment to different experimental what units. For instance, if we are talking about what Fensic, which of course is what is a drug and a level of what of that drug. When you apply the Fensic on me, for instance, you apply it on another person, you apply it on another person, you are talking about what? Replicating that experimental what treatment. So that's what we mean by replication. Application of the same experimental what treatment on experimental what units. That's what we call replication. Then when we talk about randomization, we are talking about the application or the allocation of experimental what treatment to experimental what units. That's what we mean by what? By randomization. Application or allocation of our experimental what units to different experimental treatments. Allocation of experimental what? Units to the different experimental treatments. That's what we mean by randomization. These are terms that we should be meeting often on the discussion of analysis of what? Of variance. So permit me to clean it now while we return back now and begin to discuss in detail what analysis of variance is and what we intend to use it to achieve. What do we mean by analysis of variance? Before we can completely understand what is meant by analysis of variance and appreciate it, we begin by looking at what we call two-sample t-test. Now, when we have two separate groups and we want to test the statistical significant difference between the means of two groups, we use a statistical test called two-sample t-test. I repeat, when we have two groups, or we have two levels of factors, two levels of a factor, and we want to test, or we intend to test the statistical significant difference between the means of these two groups or these two levels of what? Of a factor. We make use of a statistical test called two-sample t-test. Called what? Two-sample t-test. Two-sample t-test. Two-sample t-test. We use what we call two-sample t-test. Let me be clear here. Two-sample t-test. And the effort should be made to understand that there are different kinds of two-sample t-tests based on the nature of these two groups or these two levels of what of factor. Now, when these two groups are strictly two independent groups, when we talk about independence with regards to these two groups, we are saying that no experimental unit in a particular group is found in the other what group. Therefore, the two groups are independent. So when these two groups involved are independent, or these two levels of factors involved are independent, we make use of two-sample t-test called two-sample t-test independent measures. Two-sample t-test, two-sample t-test, independent measures, independent measures, independent measures. Consider, for instance, an illustration where application of these two sample t-test independent measures is suitable. You might be interested to compare the means between males and females in a particular class. So the class can be splitted into two independent groups, males and females. And your interest is to compare any statistical significant difference in the means of these two groups. Of course, at the same time, you cannot be a male and equally become a female. So once you are a male, you completely belong to one group. And you are a female, you completely belong to the other what groups. These are two independent what groups. The best test you are going to use at that point in time is what we call two-sample t-test independent what measures or independent group. You can equally talk about what two different schools, and the interest is to look at the academic performance between these two schools. So the interest is once you are in a particular school at the same time, you cannot be a student of the other what of the other school if all things are being equal. So there are two independent what schools, independent what students. And we want to look at if there is any statistical significant difference between the performance of the two students, from the two groups of students from the two schools in terms of the mean performance. They are equally two independent what groups. However, when these two groups involved are not independent, but that they are dependent, or the two levels of factors involved are not independent, but they are dependent, we no longer use two sample t-test independent measures of group. We use another kind of what? T-test called two sample t-test. Called what? Two sample t-test. Dependent measures. Dependent measures. Or dependent groups. In the literature, most of the time, it is written as two sample t-test repeated measures. Repeated measures. So when you see this and you see this, they mean the same thing. Two sample t-test dependent measures and two sample t-test repeated measures. A little explanation on where this kind of a two sample t-test is suitable. For instance, one wants to look at the effect of exercise on a group of what? Of students. And you select, for instance, 30 students. Okay? Then these 30 students you have selected, you subject them now to a particular what? exercise. And before subjecting them to a particular exercise, you must have taken the measurement of their what? Of their weight. And then you subject them to that particular what? Exercise. And once they are done with that exercise, you equally measure their what? Their weights. So the same set of people that you measure their weight earlier are the same sort of people you subjected to that what? Exercise, to which you measure their weight at the what? The end of the exercise. So you are still making use of the same experimental what? Units. Or you even want to look at different kinds of what? Exercise. And then you select 15 set of what? Students, subject them to a particular kind of what? Exercise, take the measurement of their weight at the end of that exercise. Then after some times, you equally subject them to another kind of what? Exercise. And at the end, you take measurements of their weight. And you tend to compare if there is any statistical significant difference between these two kinds of what? Of exercise. You are still making use of the same experimental what? Units. So these groups are not independent, so to say. Because the same set of people you use in exercise A, for instance, are the same set of people you are using in exercise what? B. Therefore, they are not independent measures. In that case, you should be using what we call two sample t-test dependent measures. Therefore, two sample t-tests are classified into two. Two sample t-test independent measures and two sample t-test dependent what? Measures. Depending on if the two groups involved are independent groups or whether they are dependent what group. And for now, I want to believe you must have understood what is meant by groups being independent and groups being dependent. Now, this two sample t-test has a limitation. The limitation there is that it cannot be applied once these groups go beyond what? 2. So once you have 3 groups, 4 groups down the line, the two sample t-test becomes inappropriate to use. And we go for another kind of what? Of test. And that will now bring us to what we have today called analysis of what? Of variance. So the moment the number of groups involved goes beyond what? 2, we no longer apply two sample t-test. Instead, we make use of what we call analysis of what? Variance. Therefore, what is analysis of what? Variance? It is a statistical procedure or method through which we can test for the statistical significant difference between the means of 2 or more groups. Between the means of 2 or more groups. One will ask question in this definition which I have given. Why do I still have to talk about what 2? Yes, ANOVA can be applied when we have 2 groups. That's oftentimes you see people define that it is a statistical procedure or 2 through which we can test the statistical significant difference between the means of 2 or more groups. That's what we do in what? In the analysis of what? Variance. It is also important for us to know that the 2 or more groups involved can be independent groups, or the 2 or more levels of what? Factors involved can be independent what? Levels. If they happen to be independent groups or independent what? Level, the particular ANOVA that we are going to use is what we call ANOVA. That's what we call analysis of variance independent what? Measurement. Just like we had 2 sample t-tests independent what? Measurements. So we have what we call ANOVA independent measurement. ANOVA independent groups or independent measurements. Independent groups. Independent groups. We can have what we call ANOVA independent what? Groups, or ANOVA independent measurements. However, when the groups involved are dependent, like I earlier had explained, we no longer use this one. We use another one called ANOVA dependent groups. Dependent groups. It is also important to note that oftentimes in the literature of analysis of variance, they write this thing, instead of using dependent groups, they use ANOVA repeated measurements. Repeated, you can either say repeated groups or measurements. Measurements. Okay? So by implication, ANOVA is classified majorly into two, based on the facts on whether the groups involved are independent or whether the groups involved are dependent. And these are ANOVA independent groups and ANOVA dependent groups. That's what we have there. So you permit me to clean down here, and when we discuss in detail this ANOVA still. If you are listening very well in the definition or explanation I gave on ANOVA, I said it is a statistical procedure or method through which we can test the statistical significant difference between the means of two or more groups. So going by the definition, nothing brought in variance here in that definition. So the concern is, why is ANOVA described, or why is this two described as analysis of what? Of variance? It is simply because we intend to make inference about the means of two or more groups by analyzing the variances that are contained in the data set. So the name is appropriate. Trying to reach conclusion about the means of two or more groups from the perspective of the analysis of the variance contained in what? In the data set. So in the real sense of it, what ANOVA does is analyzing the different sources of what? Of variations or variances that exist in our data set. That's what ANOVA does. And in this study of ANOVA, the variances involved in our data set is classified into two. The two sources are classified, or they are classified into two sources. The variance that is involved. Classified into two sources. One, we have what we call between group variance or variability. Between groups variability. Permit me to write something like this. Between group variability. And then we have the second one as what we call within groups variability. Within groups variability. So these are two sources of variation that exist in our data sets. And when we talk about variation in our data sets, effort should be made to understand that what we are referring to as variation in the source of in our data is, if you collect data via experiment or via any method, you find out that the data values or the units of what of the data vary from one another. So the concern is trying to find out the source of the cause of these changes in the units of our data. What causes this change? Why at times we have, for instance, 45, at times we have 47, at times we have 50. Why can't it be 47, 47, 47, or 50, 50, 50? Something is responsible in making the unit of this data sets what to change. And those things that are responsible in making them what change is what we classify as sources of what of a variability. And those sources of variabilities are classified into two, called between groups variability and within groups variability. So the question is, what do we refer to as between groups variability? Now, for instance, if you have a gender that is made up of what male and female, and you have given them example, right? You have computed the mean for the female, you have computed the mean for the what for the male. You have equally computed what the ground what mean from both the male and the what and the female. You find out that the mean from the what the female might differ from the ground mean, and the mean from the what the male might differ from what from the ground what mean. Remember that in this case, this female and male is referred to as what are the groups. And these groups, in this context, we are now talking about what? The means of what of the groups is varying from the ground what they mean. Is varying from the ground what mean. And in that case, we now talk about what we call between groups where variability. When we begin to take example, when we were discussing one-way, two-way, three-way ANOVAs without replications and the rest of them, without interaction, we now discuss in detail what we call between groups variability, including the formula with which we can identify that. Now, when we talk about the within group variability, we are saying that when you come to a particular group, be it that of what of a female, okay, that if you get the mean for the what for the female and you compare the mean of this female with each of the scores of the what of the female, you find out that they also vary. And in that case, we are referring to within group what variability, within each of what of the group, how they vary from the group mean, how the observations from a particular what group vary from that group's what mean, is what we are referring to as a within group what variability. And then there is a concept that we use to quantify the between group variability. And that concept which we use to quantify the between group variability is what we call the between group sum of squares. Between groups, between groups, between groups, sum of squares. So while between groups variability looks at the variation between the group's means from the grounded mean, we use a concept called between groups sum of squares to quantify this variability. And while the within groups variability looks at the variation between the observations in a particular group from the mean of that what group, we use what we call the within groups sum of squares. Within groups sum of squares, sum of squares, to quantify it. Okay? And of course, we have to pay attention that this between groups sum of square is always written as sum of square treatment. It's always called sum of square treatment. Called what? SSTRT. This SS is talking about sum of square. TRT here is referring to what? To treatment. And in this case, the within group sum of squares is always referred to as what we call sum of the square errors. Sum of square errors. S what? E. S here means sum of squares, and this E here is talking about what? Errors. And ab initio, we had said that there are only two sources of what? Of variability in our data set, given as this. So by implication, the total variability in our data set are the between groups variability plus the within groups variability. Which means if I talk about the total variability, it will be given as within groups variability, between groups variability, between plus within groups variability. Okay? And like I had earlier said, we quantify this with this, we quantify this with this. So when we want to quantify the total variability, we talk about what we call total sum of squares. And this total sum of squares is always written as SST. So which means my S what T is given as my SS what T and T plus SS what E. We are going to meet this much later when we want to begin to take questions to solve. So you are going to permit me to clean this board. When we clean this board, we also talk briefly now on other kinds of other dimension of what? Analysis of what? Of variance. So permit me now to clean this. It is important to note equally that we have other classifications of analysis of variance depending on the number of what? Factors or independent variable that are involved in that what? Research. For instance, you don't cure illness alone with drugs. You can place someone on diet, especially when it has to do with diabetes and some other related what? Diseases. So in this case, we are looking at what? The diet that the patient is placed on as a factor that, of course, its effect can be studied in that person. And we are equally giving that person what? Drug. So in this case, there are two factors what involved. So, and then in that case now, we are now saying we have analysis of variance where we have only two, where we have what? Two factors. However, in another scenario, you might not place somebody on diet. You are treating that what? Diabetes now using drug alone. So if you are using drug alone here, the factor involved here is what? Is 1. And if the factor involved is 1, the kind of ANOVA that we use is what we call one way. It is called what? One way. One way, or you call it one factor analysis of variance, ANOVA. Okay? You call it one way or one factor analysis of what? Of variance. When only one factor is involved. For instance, you are looking at what? At a drug, where this drug have different kinds of levels, like I earlier had explained, in terms of Fensic, Panadol Extra, and the rest of them. Now, however, when you are placing the person on diet, and this diet, of course, have different levels, okay? Then you are equally giving the person what? Drug. In that case now, two factors are what? Are involved. Diet and then drug. And in that case, The kind of ANOVA you are going to use becomes what we call the two-way, two ways, or two-factor. Two-way or two-factor ANOVA, analysis of variance, ANOVA. This is the kind you use when you have two factors involved. Okay? You can equally have more than that, where perhaps you are giving the person drug, you are placing the person on diet, and you are subjecting the person to exercise. And some other things now you can feel can have effect on curing that person's sickness or diseases. So in that case, you have what we call the multi-factor, or what we call the factorial ANOVA. And what we call the multi-factor. Multi-factor, otherwise called factorial ANOVA. Factorial ANOVA. So what I want you to hold in the hand in this class for now is, in one way or one factor, a single factor is involved with different levels. In two-way or two-factor ANOVA, two factors are involved, each of the factor with different levels. Then in a multi, it's more than two, from three and above. You either call it multi-factor or you call it a factorial ANOVA. And do remember that if the levels of the factor involved here are independent levels, the one-way ANOVA we are going to use become one-way ANOVA independent groups, because the levels of the factors are what are independent. But if the levels of the factors are dependent, the ANOVA we are now going to use now becomes what we call one-way or one-factor analysis of variance dependent measurements. The same thing applies to two-way, the same thing applies to three-way analysis of variance. So this is going to stand as an introduction to analysis of what? Of variance. In the next class, which we are going to begin immediately, in order to help us manage the size of the video we already have, we are going to be looking at what we call one-way analysis of variance, independent groups. One-way analysis of variance, independent groups. That is analysis of variance where we have a single factor with different levels, and these levels involved are independent levels or independent groups. We are going to look at it in these following dimensions. We are going to look at what we call the statistical procedure of carrying out that kind of analysis. We are equally going to talk about the data layout of the one-way analysis of variance. We are going to talk about the ANOVA table of one-way analysis of what? Variance. And then on how to make inference about it. Therefore, stay put and wait for our next class, which is coming up soon. Do remember to subscribe to our YouTube channel, share our videos to reach the rest of the people. Thank you very much for your audience.